Hi, my name is Carrie Eaton, and I'm the curator here at the UW-Geology Museum. I'm going to be talking to you today about some minerals. Minerals are all around us. There are more than 5,000 species of minerals that have been identified on Earth today. A mineral is just a solid chemical compound with a specific chemical composition and a specific crystal structure that occurs naturally. The part I'm going to be showing you today has to do with that crystal structure. All the minerals we see around us have a certain shape or structure, and the shape in which a mineral grows is determined by how its atoms, ions, and molecules are all arranged together. Now in geology, structures that are alike get grouped into the same crystal system. The minerals I'm going to show you today are actually part of different crystal systems, but they are all particularly spiny and spiky. The first mineral I want to show you is this Scolocite. Scolocite is a zeolite mineral, which means that it has water incorporated into its structure. This mineral often grows in these long needle-like clusters. Another pretty similar zeolite mineral I'd like to show you is this one called Mesolite. Now Mesolite is in a different crystal system from Scolocite, but you can see here that it also grows in these spiny, spiky needle shapes. Now a mineral that often occurs along with zeolites is this one here. You can see here in this geode, this is Oconite. Oconite is not a zeolite mineral, it's actually a silicate mineral, which means that it has silicon and oxygen in it. But if we look up really close to the inside, you might be able to see why this mineral is called the cotton ball of minerals. That ball inside the geode is actually made up of a radiating cluster of small little fibrous needles. And if we look at the outside of this geode, you can see evidence of where so many of these kinds of minerals are found inside the vugs, cavities, and openings of volcanic rocks. Another spiky mineral I really like is this one here called Danbrite. Danbrite is also a silicate mineral, but it actually has boron in it, and it can be harder even than quartz. Boron is actually only produced when cosmic rays hit other stuff, and also from the supernova of stars. So it's a pretty rare element in the Earth's crust, and it's even a rare element in our solar system. Now conversely, a pretty common mineral you've probably heard of is this one here. It's quartz. And you can see this quartz cluster has a pretty spiky and spiny shape to it too. If I hold it up close, you might even be able to tell that the tips of these crystals are tinged with a pink and reddish color. Now, the color variation in minerals often comes from the different impurities or inclusions or the incorporation of other elements like titanium, manganese, copper, and even iron. Now, the last one I want to show you today is pretty cool. It is not only a long, spiky, spiny mineral on its own. This is selenite, but this crystal is actually made up of a whole bundle of fibers all growing together here. Now, this piece of selenite comes from the Chihuahua region of Mexico, which is well known thanks to the discovery of a very large cave called the Cave of Crystals. Now, the Cave of Crystals is full of enormous selenite crystals, some of which are the largest known crystals to have been found on Earth, the longest of which is 39 feet long. That's one big spiky crystal. So, thanks for joining me today in looking at these spiny minerals, and I hope you enjoy the rest of your UW Geology Museum open house and UW Science Expeditions experience.